Hello and welcome back. I was working on another video prior to and instead of this one, but the release of MVDream, a text-to-3D implementation, was released quite recently, and it fit right into what I was working on anyway, which is using AI tools along with 3D techniques to rapidly world build an intellectual property, or IP. In the first half, I'll be going over the repository MVDream, or Multiview Dream Booth model created by ByteDance researchers. If you didn't know, ByteDance is the parent company of TikTok, so the content should be quite good. It also has one researcher from the University of California, San Diego. Anyway, there are two repositories for MVDream. The first one is the vanilla MVDream, which generates a 4-perspective view of the prompt. You can think of this portion as perspective-aware text-to-2D reference sheet. The second repository is the MVDream-threestudio repository, which can be thought of as a text-to-3D mesh model. It generates a neural radiance field, which can later be converted to a mesh. In the second half, I'll be using the 3D models that I generated to construct an interior living space for the main character of a web novel I wrote. Without further ado, let's get started. The portion of MVDream that I was really interested in was the text-to-3D capability, but it's important to first see the underlying foundation of the 2D version. As mentioned before, the repository for the 2D implementation can be found here, under the ByteDance organization. If you look at the paper or the repository, the developers mention that they fine-tuned their MVDream model using Stable Diffusion 2.1 base model, and they used 256 by 256 resolution, but there were 4 images in it. More on this later. The reason why I felt that MVDream was pretty promising and warranted a video/deep dive is that they correctly identified the issues with generating multiple views or reference sheets of an object. Notably, the problems identified are the multi-face Janus problem and content drift. The Janus problem is where an object has view inconsistency. You can see that this horse has a head in the back and a head in the front. So it's kind of like a Ouroboros situation. It's named after the Roman god Janus, who is often depicted with 2 faces, right here. Fun fact, Janus is the god that represents the transition between one state and another, such as the past and the future, or in this case, the anterior and posterior views. The second issue of content drift is a situation in which the prompt and the output start to diverge in their understanding or meld together. So in the figure 1 here, it says that you want a photo of a plate of fried chicken and waffles, but you have fried chicken on the top, but it slowly melts together and becomes a waffle, which is what you don't want. The paper is pretty thorough, and the authors even go over the dataset preparation in the appendix. So if we jump there, it's after the citations. We can see that they're using renders of 3D objects from this public Objaverse dataset. Before we jump into the methodology of how the authors solved the 2 problems mentioned before, namely the multi-face Janus and content drift, I want to give some context on the training data. To put it simply, they are 4 monocular 2D RGB images of the same object, with each taken from a different camera angle. The initial angles and elevation and camera field of view are randomized in these ranges. So here for elevation 0 to 30 and random camera field of view from 15 to 60. However, there are some extra camera parameters here, these ones, and I wanted to point that out because this information is also passed in and initialized in the MVDream network as an embedding. Using the parameters that they selected from here to here, you generate 32 perspective viewpoints of a specific object. So it's 360 degrees divided by 32. So you have an incremental angle of 22.5 degrees, or pi divided by 4 radians. The authors also mentioned that they started rendering from the front view. So directly facing you, you would say the azimuth is 0 degrees. If you don't know what azimuth is, Just imagine that you're standing on a large sundial in the center. When you rotate your body to face another number on the sundial, the amount of rotation is the azimuth angle. So say I'm standing in the center and I'm facing the number 12, and then I rotate my body so I face the number 3. If you look on the hands of a clock or a sundial, you can see that I moved 90 degrees in that direction. If you have the initial view, whatever it may be, let's say it's 60 degrees, the remaining 3 views are selected orthogonally to it, so just rotated by 90 degrees each time. So you could have a training set for one object that would be 45 degrees if that's your initial azimuth, and then you would have 135 degrees, 225, and 315. Now that we have some context behind the training data, we can better understand how the multi-view diffusion model is distinct from other text-to-3D models. In Figure 3, the authors point out 2 key implementations. The first one is the addition of 4 perspective views as training data. To account for this change in input data format, the authors changed the existing 2D self-attention layer to a 3D self-attention layer. So if we go down here, this is where they say that. What this basically means is that when processing an object with multiple views, each perspective can consider information from other perspectives to generate a more consistent and cohesive latent space. And they said that after making this change, they were able to generate rather consistent images even when the view gap is very large. So this is very promising. The implementation for 3D self-attention is in this file, which is the Python file named attention.py under the modules directory. You can see here that there is a basic transformer block 3D class that extends the basic transformer block. We can go ahead and take a look at that. If you look here, you can notice that there isn't anything denoting the amount of perspective views. But if we go to the 3D block that extends this class, you can see right here that there is a parameter or argument called num frames. Basically, this num frames is where the number of different perspective view renders are specified. You can also see that it has a residual connection as attention 1 and attention 2 are added to each other. So if we go and look at the figure, so figure 2 here, what I just went over before previously was the self-attention from 2D to 3D, and now the second implementation was adding camera embeddings for each view. You can see here that they have camera and it's added to time step. If you don't know what time step or time embedding means here, it's just the current step of the diffusion model, but encoded in an arbitrary tensor or matrix. When doing your diffusion generation, you're always setting the step count. Anyway, in the code, the final embedding is represented here in the OpenAI model Python file under the diffusion modules directory. If you go to the Multiview UNet model, so this class right here, you can see the initialization of the time embed right here, so self.timeEmbed, and the camera embed here as well. If we jump down to the forward pass of the same class, you can see here that it starts off with the embedding being the time embed. Down here, the embedding has a self.label embedding added to it. I'm not exactly sure what this is, but I think if it exists, then it's added. And afterwards, finally, the final embedding has the camera embedding added to it right here. So whatever the paper said was happening, it's definitely happening here in the code. Just for reference, regarding the camera embedding, I assume from the dataset preparation in the appendix that the camera parameters are just whatever is mentioned here in the paper, but I am not 100% sure. So I dug a little bit deeper in the code, and there is a camera utils Python file where it does seem to take in those parameters mentioned before, such as elevation, azimuth, and it does the normalization for the camera matrix, and it gives you a final camera matrix right here with the create camera to world matrix. So there we go. Now that the theory is out of the way, let's get to utilizing this repository. I'll be using Ubuntu on Windows Subsystem for Linux 2 to guarantee the least amount of compatibility issues. I have tried using both the 20.04 version and the 22.04 version, so I think on my PC here, this one, I'm using, yes, 20.0.4. The installation for this part is pretty straightforward. Just git clone it from the repository. I've already done so, so if you see I have MVDream, so let's just go there. Once you're in, you can create a virtual Python environment like so, like python-m vnv-vnv. Once you're in, you can create a virtual Python environment. I've already done so, but this is the command to do it, like that. So I won't be doing that, and we can just ls and see I already have it right here. To activate your virtual environment, type in source vnv or the name of your directory, and then activate. Pretty straightforward. And then you can see that my virtual environment is activated now. All you have to do is just install the requirements. So this part is pretty simple, like that. And you should be good to go. Once all your dependencies are installed, you can use it by either running this command here, or you could start up a Gradio front-end server. So let's just go ahead and use the Gradio server just to see what we're doing visually, and start up the server. It's doing its thing right now. Okay, so the script has finished running and it's told us that it's at our localhost 7860 port. So let's get to it. Once you head over to port 7860, you can see that there is a simple UI here for you to use. There's also some examples preloaded in already, so let's select some of those and see what we should expect. So astronaut riding a horse, an earth, cute cat, and then this one doesn't look that great, but this one is actually surprisingly interesting. You get a ship and it's pretty good. One thing I want to note is that I think the first row of images up here is the coarse version and the second version down here is the refined version. I also noticed that it removes the ground plane. So if we just look at it, the pedestal here is removed. This one didn't have it. This one had the pedestal removed as well. So I'm not exactly sure what the difference is because I looked in the code and they seemed pretty similar. Now let's go ahead and try it for ourselves. I'm going to keep elevation and azimuth at their default, and I'm not going to use a negative prompt because it seems like it's not really necessary. This is one I tried using already. This is a sci-fi glass panel. So this is a pretty interesting design. I didn't specify a color here, so I can just add in something like black color scheme and see what happens there. Right now I have this very flat image. I could probably do some perspective warping in Photoshop and get something that I could use as a texture in 3D. I ended up changing to a black color scheme and now I have something like this. You can see that the view is preserved, if that makes sense. Here you could say it's the anterior view or posterior view, depending on what you want to think of this as. And then when you look at it from the back, you should have a flipped image, right? So yeah, it seems pretty consistent with what I'm working with. Next up, let's try using a different prompt and making a bit more of a complex prop. This is something I tried using already, and it's a Japanese kitsune mask. It's one of those fox masks you've probably seen at Matsuri's or something like that. We have something like this. It doesn't look that great, but it does seem to be consistent. In the vein of Japanese culture, what if I want to generate a uniform that goes with this? So I'll go ahead and put in this prompt, which is a Shrine Maiden uniform. Let's see what this gives us. And we have a figure in the first row, but it gets removed and it becomes this fashion statement right here. Lastly, let's try a human. So I'll put in this prompt, which is just a young man. We have something like that. So it's not bad. It's actually pretty good for fast concepting, and you could probably use this for reference image or reference sheet generation. Lastly, I want to try one more thing, which is probably like a sci-fi vehicle. So here we go. Sleek, futuristic sci-fi vehicle. We have something interesting. The coarse looked pretty strange, but the refined looks pretty nice actually. There's a lot you can do here. Now that we understand the interlude or interstitial method of generating contextually aware perspective views from a text prompt, we can get into the real exciting part, which is the text to 3D section. The theory for text to 3D is kind of glossed over quickly in the paper in section 3.2. On a high level, what seems to be happening is that the 2D MVDream model shown previously is first used to generate 2D reference images, and then used in tandem with an adjusted score distillation sampling method, which was first introduced in the paper Diffusion. So right here, and it's written by the author pool. In addition, they say that they're using the camera parameters from before as well, instead of using direction annotated prompts. I assume this means that when they're prompting in Diffusion, they're using front view, side view, posterior view, prompts like that. Anyway, the four perspective view outputs from the 2D MVDream model along with the camera parameters are processed by guidance modules to create a neural radiance field or NeRF. If you have multiple different viewpoints, you can infer the final 3D scene, aka a NeRF. As for what a NeRF is, it's a neural network model that learns how light rays interact with surfaces in a volumetric representation. This is different from a 3D object, which is a geometric representation. If you have a NeRF, you can get a 3D object using various transformation techniques. In this case, if we go down a little bit here to section 4.2, the authors mention that they used a multi-resolution hash grid to transform the implicit volume of the NeRF to a 3D OBJ file. Before I finish up on the paper, in the same section, the authors mentioned that they polled users on how well the MVDream model performed. On average, 78% of users preferred the MVDream over others. So this gives us an idea of how promising this MVDream model actually is. However, why speculate? Let's try it out for ourselves. This time, the installation of the repository for MVDream-threestudio is a bit more convoluted. Once again, I'm using Ubuntu on Windows Subsystem for Linux 2 again. So here I am, and you can start off by just git cloning the repository. So code https, just copy that. I've already done so. If you ls, you can already see that I've cloned it in here. Once it's cloned, just go ahead and cd into it. Once you're in here, you have to do one more git clone. If you scroll all the way down here to where it says install MVDream, there's a list of commands here. So you don't have to do this part right here. All you have to do is just copy this first line. And then there you go. Let's go back and try it out here and just git clone that, and see it says it already exists. Let's just go into extern and see. And you have everything here. The reason why I'm not going to do this pip install -e here is because I'm going to be doing that in the Docker file. Speaking of the Docker file and the Docker Compose file, that is what I'm going to be using to set up the virtual environment. If you scroll down here and go to the installation markdown file here, it'll give you some steps you can choose. You can either do it vanilla here, or you can use Docker. This is what I ended up going with. So if you don't have Docker Engine installed for Windows Subsystem for Linux, you'll have to go ahead and install that. I'm using Ubuntu, and if you want to follow along, you should click this second link right here. Once you click on it, it'll take you to this page. And first up, you should start from here. Install using the apt repository. Just copy that, come back over to your terminal, and let's just go up one level. and paste it in, and it should do all that stuff. I've already have it added in, so that's why it's like that. And then let me just run sudo apt-get update. And then once that's done, let's just go back and look at the next step. We have to run this sudo apt-get install docker ce. Just copy that. Come back here and go again. And I've already installed it, so you can see that it's not installing anything new. So if we go back to the installation markdown file, we've installed Docker Engine. You can create a Docker group if you want. You don't have to, and if it's too much of a pain, you can just skip it. Next, it says to install the NVIDIA Container Toolkit, but we can do step 4 first because we're already here in the terminal. So it's telling you to enable systemd. Just click on that, go here, and this is basically how you do it. The reason why you want to do this is to enable systemctl Linux commands on Windows subsystem for Linux. To do that, create this file here. So let's just copy that, go back to here, just clear everything, and then I'm going to be using Vim. So just type in Vim and then that, and then it'll open that up. I've already added this in, so go ahead and add in the same thing written here. And once you have that, you can just quit out or WQ. Next up, you can restart your Ubuntu system for good measure. So just close it and then reopen it. I'm not going to do that because mine is working. And all you have to do to check is just run docker run and then hello world. And yes, hello from Docker. This message shows that your installation appears to be working correctly. So Docker is working in our Ubuntu for Windows right now. Next up, remember the step that we skipped or rearranged in the order, which is step 3. We have to install this NVIDIA Container Toolkit because we want to enable CUDA inside our Docker containers. So let's just open that up. And same thing, if you want to install with apt, this is what I suggest to do. Just clipboard, copy, and let's go back to Ubuntu. Paste it in, go, sure, overwrite, why not? And it's done. Next up, we have to install the NVIDIA Container Toolkit packages. So copy that, go back to the terminal, same thing. Done. Go back again. We need to configure it. So we have these two commands that we have to run. So first off, copy that one, come back here, done. And then it recommends that it be restarted. So let's go back here to get our restart command. Here. And paste. Done. And let's just check again with a docker run hello world. Great. Nothing's broken. Now we have to edit some of the Docker files inside the Docker directory, namely the docker compose.yaml and also the Docker file. These are changes that I made on my own because I was unable to do certain things with the container that I wanted to do, such as making sure that every time the code runs, I'm not re-downloading the model files. I wanted to create a bind mount so that these volumes will store the downloaded models. I'm going to use Visual Studio Code to edit my Docker file and Docker Compose files. However, if you don't know how to get to the location of Ubuntu on your computer, I understand. To do that, just go down to your terminal, type in explorer.exe and then a dot. This will open up the current directory in a file explorer. So just do that. And then let me change the display. So this opens up. And if you go up here, copy that, and then open up Visual Studio Code here, and then just create a new window, move it over here, open folder, paste in where I was before, and there we go. what I said I wanted to change is the Docker files, so compose.yaml and Docker file. First off, you'll notice that there's this part in line 14 and 15 where it says environment torch CUDA archlist and tcnn CUDA architectures. I've set mine to 8.6 and 86. This is for RTX 3000X series. If you would like to understand what values you should put in here, you should visit this website right here. So I said I'm using a GeForce RTX 3090, so I'll go down here to the fourth bar, open that up, and you can see on the left side right here, if you're using a 3000 series, it's 8.6, and if you're using a 4000 series, it's an 8.9. The secondary changes that I made to this Docker file are starting from line 64 down to 87. I was running into some permission errors, and I also wanted to make sure that the cache of the model download was being saved. I also made the corresponding changes in the Docker compose file. I added this /huggingface_cache as the bind mount. So I've made my Docker files available here. So the Docker file and the compose file are here on my own repository. Here, kudorera. Just go to your repositories and then go to MVDream_docker. So yeah, here you can see I have the Docker file here and the compose file here. So you can just copy the same settings that I'm using and just account for the proper GPU on your machine. Here I have 8.9 because I have 2 workstations. Actually, I have 3 workstations. And one of them is dedicated to training machine learning models, and that has an RTX 4090 in it. So we're back in Ubuntu now. Everything should be downloaded. Everything should be configured correctly. All we have to do is build our Docker image right now. So I'm going to clear everything. And before I do anything else, I'm going to open a tmux session. So this enables you to have 2 windows open. You'll see why. If you're not confident with this, you can just open a second Ubuntu window. No shame in that, but I'll be using tmux. So I'll just go tmux, new, -s, and then your session name. So I'll just call this MVDream, and there we go. Now, if you want to open a split pane window to work with, you can. So the command is Control-B and then %, like this. And then it'll bring this up in the bottom left. I want a horizontal split, so I'll just press H right here. And then I have my second pane over here to the right. If I want to move between panes, I have to press Control-B and then left or right arrows like so. So high and then high 2. Very easy. Now on both windows, I want to move to the Docker directory like that. So I'm in Docker right now. First up, I need to build the image. So it's pretty simple. Just type in Docker compose build like that, and it'll start building. This takes a very long time usually. This is fast for me because it's all cached already. If it's not for you, most likely you'll have to wait a really long time, maybe like 30 minutes at least, to download all the dependencies and build the image. Once that's done, you can start the container by going with Docker compose up. Once that's up, it starts up the Docker container. However, once the Docker container is running, how do you get into the Docker container? That's why I opened a second pane on the right. So to switch over there, remember Control-B and then right arrow. Here I am now. To enter the running container, make sure you're also in the same Docker directory where Docker compose was ran. So cd docker, here I am. There are my Docker files and my compose. So type in Docker compose exec. This is to get into the existing container. Then you'll need the existing container's name, which is 3studio, and then bash. And now I'm in. If you have a discerning eye and look inside this directory, you'll see that there's a Gradio server file actually included. So I'm going to start it up and show you why I don't use it. So Python Gradio underscore app.py launch. This is the command that was given on the website. I can go ahead and show that to you guys. So here is the Studio repository, and this is what is used in MVDream-threestudio. I'm just here because there's more information. They start up the Gradio server with launch here, Python Gradio underscore app.py, and launch. However, since we're running in a Docker container, we'll have to add the flag listen here. So -- listen. This means that the port will be exposed on 0.0.0.0 as well. So let's just go ahead and run that. Okay, so now you can see it's available here. So let me go in here, 7860. And now you can see that we have this Studio text to 3D web demo. And if we go here, we can go down and select a model and then click on that, SJC. But interesting enough, there isn't a MVDream config here. So if we check this, SJC, this config here does not resemble the config that MVDream has provided. So let's jump into Visual Studio Code once again. Here we are. If we go to configs directory here and we go down to MVDream st21.yaml, this is what the configuration file should look like. Hash grid, as we mentioned before in the paper, has this. So I don't think the Gradio server GUI is the way to go on this, and I definitely did not use it. So next up, I'll show you how I used it from the command line. One note of warning while we're here is that if you run into out of memory issues or OOM issues for your VRAM, you can come into your config file, depending on which one you're using. I cannot use the shading one because you need a more powerful GPU. If you have a 24 gigabyte VRAM GPU, you probably will just use this one that's non-shading. So if it's not working or running out of memory, just search up rescale and find that. So here it's set at 0.5. If it doesn't work right now on 0.5, you can go lower like 0.2. I've gone as low as 0.15 because my GPU had trouble creating some NeRFs on some prompts, but on other prompts it was fine. I wasn't sure why. But once I lowered this rescale value to around 0.15, everything worked fine. As we saw from the Gradio server, it seems that the necessary config is not there. So we'll be using the command line to generate the neural radiance field. The commands are executed in two stages. First, you generate the NeRF. So it would be this command here. And then afterwards, once you have your NeRF created, you'll use that to export a mesh. I've already lowered my rescale value as I encountered out of VRAM memory issues in the configuration file. I'm also electing to use the vanilla mvdream.yaml file, so this one, as opposed to the shading version, because this one requires an A100 GPU in most cases. As I said before, this is the first stage of the command. You might notice that there isn't a negative prompt, because there already is a negative prompt in the config file. The default training steps is 10,000, so let me just look that up. Yeah, trainer max underscore steps 10,000. And this takes around 30 minutes to 45 minutes. So let me switch over to my other workstation. The Ubuntu version on this computer is 22.04, but it doesn't make a difference because we will be using Docker. Let's input the training script now. If you remember, I generated a kitsune or fox mask in the 2D version of MVDream. It would be a good comparison to see how the 2D and 3D versions stack up against each other. So this is why my prompt is like this. Let's go ahead and enter, and it's starting up right now. When this first starts up on the very first run, it will download all the models necessary. I think it's only one model, but it's only done once, and it'll be cached because I set the Docker Compose file and the Docker file to store it in the Hugging Face cache. So you can see here, loading model from cache file. Excellent. So we'll just let this run. You can see 4090. And then now you can see that it'll start running down here. This is the number of steps, and it'll stop when it's at 10,000. So you can probably expect values around this range if you're using a 4090, just for sanity's sake. Once the script is done running, you can check it in the outputs right here. However, you don't want to check it from inside the container, so you want to check from outside the container because they are mapped with a bind mount. If that doesn't make sense to you, don't worry, it's just Docker things. So since I'm in Tmux, let me just create a new window pane like that. And then you can see that I'm not in the Docker container right now. I am outside in the MVDream-threestudio, and cd outputs. Then you cd to MVDream, like so. And you can see I have this many because I was playing around with a lot of different prompts. Once again, if you want to find where this is in your file explorer, explorer.exe, and then a dot. This will open up the file explorer here so you can see what's going on. So let's go ahead and look for the mask. I'm not going to use this one. This is just for demo purposes. I'll delete that one. I have an older version. Click on that. You'll have a checkpoint here that's called the last checkpoint. This will be used for the mesh exporting later. But first off, let's just check what we have, which is in the save directory. So click on that. And then you won't have this export because this is for mesh. And then if you look in this folder here at the very end, there's a video. So let's just click on that. This is the video or the NeRF. Not bad, right? Now that we have our neural radiance field, we want to convert it to a mesh, and the export mesh commands are found in the threestudio project repository here. And in export meshes, you have a slew of options that you can choose from. However, simple is best. You can just run this one right here. So if you're using this, there is a few gotchas. First off, make sure you input the folder paths correctly. It gets pretty complicated because you'll be using an absolute path. And lastly, you'll have to add one more thing after the system exporter type equals mesh exporter, because if you go here and look at the documentation, or when you go to the installation here, this is probably better. Installation markdown file, you can see that there is a warning here that says that the current Docker file will cause errors when using the OpenGL based rasterizer. So you need to set this when you're exporting your mesh. So context type equals CUDA. So this is an Obsidian file I created for this project. It has all the commands I need, and I also write down notes in this as well. So if we go ahead and just look at the exporting script for the mesh, it's pretty nasty, but it's not too complicated. Remember, all you have to do is find the absolute path and make sure that you have the configs and the parsed.yaml. That's the first step. And the last one is to make sure you're resuming from the last .checkpoint file. And then lastly, you need to have this exporter context type equals CUDA. So let me just copy that, and we'll head over to my other workstation. Here we are. Let's move back to the container. So Control B up arrow, and just paste in what we had in the Obsidian file. So here we go. You can see it's doing its thing right now. It's using XAtlas to perform UV unwrapping, which basically means you want to project a texture onto a UV map, and then it's exporting the textures, doing stuff like that, and then it's done. You can see it says export assets saved to outputs here. it's in the save directory, which is where the video was as well. So we can just go back here. Remember, the video is all the way down here. And then we have this export here now. So let's go into it. And we'll have an OBJ file, which is our 3D object. And then we'll have a material file as well as the texture. So let's just open up this object in a 3D package. I'll be using Blender because it's free, so you can follow along. Here we are in Blender. Let's go ahead and import the OBJ file. So file, import OBJ, right here. And this is where my files are. Go here, and remember it's in save and then export. And then just click on OBJ and it should be in here. If you take a look at the mesh quality, it's not superb. However, if you do smooth it, shade smooth, it looks a little bit better. Let's just rotate it so it is facing us. Like so. Move it up. Actually, I prefer it like that. You can go ahead and set the origin. So origin to geometry. Yep. And then we can turn on the render settings. Make sure you're using something you're comfortable with. I'm going to use cycles and GPU. So let's go take a look. This is what it looks like. Let's change some of the environment. Make the background completely black. And then I'll have to add a light, but first I'll add a plane. Okay, so just do a 1-point lighting setup, like so. Then maybe we can turn up the intensity of the light. So maybe 500, too strong, 250. Just go with 150, I guess. Yeah. So you can see that it's pretty good, actually. It reminds me of a voxel mesh. This could also be a great starting mesh that you can dynamesh in ZBrush if you want. But yeah, this is quite good. And then let's just look from the back. Sure. As a placeholder mesh, this could be very, very useful. As an aside, if you're not satisfied with the mesh quality, you can try a second stage refinement. If we go to the paper in section 4.2, if we look at this sentence, the authors say, Magic 3D performs relatively better by using DMTET for second stage refinement. If we go over and look at the GitHub issues for the MVDream-threestudio repository, there's someone asking a question here, Reynold SCEM. He asked recommended export settings, and then one of the maintainers of the repository, Season SH, he said that our experiment mainly focused on NeRF generation, and you can follow these steps. And he said that you can use a second stage refinement as well. So he's just echoing the sentiment in the paper. So if you're interested in running a second stage refinement, you can follow what Season SH said. Just click on 3Studio, head over to the repository, and then there should be a refinement portion in the markdown. So here we go. You can think of the core stage NeRF as the first step that we did. And then the second stage would be, instead of having the mesh exporting, you would do a second stage refinement. As mentioned in the paper here, it says Magic 3D. So here it's also using the Magic 3D Refine SD.YAML file. So if you're curious in running this, just copy this and make sure all your file paths are consistent. So of course I was curious and I did try a second stage refinement on the original Kitsune mask. If we head over to save and then look at the video, we get something like this. You can see that the design has completely changed, like so. So you can see that it gave me a completely different object because it had to refine on the same prompt, but it was using a different model and configuration. So after it was shown to be this, I ended up choosing not to export this as a mesh because I didn't feel like this was any better. You can see that MVDream performs pretty well for a concept sheet generation or a rough base 3D object blockout. I ran the MVDream-threestudio on a few more varied prompts, and here are some of those objects here. So go to render mode. Here we have a Gundam, which is actually pretty nice looking. If you zoom in, it's all broken, but if you're looking from far away, it's not bad. And then we have a chibi vampire right here. Yeah, it's nice from far away. And the silhouette blockout is the most important part of design. So this is great. Next up we have some clothes. This is the Shrine Maiden outfit from the 2D generation. I just ran it on the 3D, same prompt. And yeah, it's interesting. You could definitely do a lot with this if you wanted to. I have some other props as well, such as this desk here. A feathered plumage up here. It could be like a quill or something. And then a bone knife. If you think about it, especially if you have no 3D experience, doing a 3D blockout will take you some time, even if you're very experienced. It could be 15 minutes or it could be at least 40 minutes. So this is very, very quick generation, assuming you have a powerful GPU. Lastly, we have this bed right here. It's pretty big. Maybe I'll just scale it down. Since we have 3D objects, we can do some cool things now, such as rendering out these 3D objects and then using them as ControlNet images to direct our brainstorming phase or process. I have one in particular that I want to experiment with, which is this vehicle, this four-wheel futuristic vehicle that I got out of MVDream. So let me go ahead and set up the lighting. So let me turn off this global area light and then turn on this area car like so. And I think I already have a camera for this. Head over here. I think it's this one. No, not that one. This one. One thing to note is that I've set up two scenes with different camera resolutions. So this is if you want a vertical aspect ratio, and I've set it already to the dimensions that are on SDXL, so 896 by 1152. However, if I want to switch over to a more horizontal aspect ratio, I've already set up a scene for that. So if you go up here, go to scenes, and then just double click on that scene. And then here I am. And I'll just have to turn off some of the objects. So back to view layer and turn off everything in here and just enable the vehicle. So there we go. And we can go ahead and just render this out. Here I am in my ComfyUI setup. I am using Surge SDXL and I'm using the latest version, which is 4.2. Just for reference, let me go ahead and load in the workflow that I'm going to be using. I set up my prompt already here, and I'm using the SDXL model that I trained in my previous video. This is the prompt: an elegant futuristic four-wheel vehicle, silver metal finish, intricate design. And I've changed the preset for the aspect ratio to a 21:9, so it's 1536 by 640. Now, all I have to do is come down here to the ControlNet or revision source windows, and I'll just have to replace this. So let me just drag and drop in my render. Here we go. There we go. There it is. And let's just try it with Canny right now. So this is the first generation. It's not perfect, but it is looking pretty interesting. So maybe we have to change some of the ControlNet settings. Turn down the Canny to around 0.55 or maybe 0.6, and I turned down the end percentage so it was not controlling too much of the design. And I got this, which looks pretty nice, and I'll just generate one more for good measure. Here I am in XNView MP, my image browser, And we can just go ahead and take a look at some of the unique designs I received. So these are all very, very cool. I like this one. It's like a dune buggy sort of design. Yeah, this one, nice. Very cool. This one kind of looks like a tractor or lawnmower. Snowmobile. Kind of like a NASCAR kind of thing going on. Formula One. Yeah, Formula One right here. Like a Porsche. Yeah. And here we go. This is the one I think that would be very nice for a product render or something like that. Now, I'm going to start showing how and where MVDream and its 3D objects could help in the art process. You might have noticed a trend already with the objects I was generating. My ultimate goal is to design an apartment or room or living space for the main character of an imaginary story. I did some preliminary generations for the character, and these are what I ended up with. I really like this futuristic look, but also simple. And I think there's one that I liked in particular. Yeah, this one. So I think I'm going to base the character design around this version, but we'll see how the room designing goes first. Regarding the background of the story and the character, I wrote a web novel a long time ago that I didn't really share with anyone except for some friends. For reference, that was maybe 7 years or so ago. The setting is of a post-apocalyptic world where countries are cut off from each other because of mutated radiation. There was a World War III, and because of the fallout, there is miasma. Anyway, the story follows a young woman who is an informant in the underground or dark side of the new world. If you've read Toaru Majitsu no Index, it's pretty similar to like the underworld battles there, like they had group in school. Those characters, I really resonated with them. And I don't really see stories that often focus on the anti-hero or people who do corrupt things for corrupt reasons just because they can. So I wanted to write a story similar to that. Let's get back to the objective, which is interior room design for this character. I generated some potential room setups for her, and these are the ones that really resonated with me, so let me just bring them up. So it's very standard sci-fi. I wasn't sure if I wanted to have a visible view, but one thing I like is this wide curved display. The chair is not very futuristic, it's still like a gaming chair. This is the keyframe that I think I'm going to base the room around. It's very minimalist and clean, which I really enjoy, and I think it fits in well with the main character's personality. But I generated a few more just to see what was out there. You can see that when you're using diffusion models, it's not very imaginative with the chair, because if you type in chair, it just gives you a chair. It can't give you anything really insane looking unless you try to choose that. I did end up having some other chair designs that I can show here. There's two in particular that I really enjoyed. The first one is this one. This is very cool. It kind of reminds me of a motorcycle helmet, or in Sword Art Online, they have the full dive gear they put on a helmet. This is cool. And there's another one I like, this one as well. This one seems a lot more like you're sitting in a cockpit or like a racing car, something like that, and you're reclining backwards. I really like this design too, but I don't think I can explore it in the concepting phase because this is just too complex to model. Before I go any further, I want to first generate a floor texture. If we take a look at the floor in all of these images, so like this or this one, you can see that it is a shiny, slightly reflective floor. I'd like to also add some texture to this floor by making it a marble texture. So let's head into ComfyUI to set that up. Here I am in ComfyUI and I've input my prompt right here. So it's pretty standard, my trigger word, and just marble floor texture. All I'm looking to get out of this is a square image. So 1024 by 1024, so a 1K image, and I'll upscale it right after. So let's go ahead and see what it gives me. Here we have it. This is the first texture. It looks very nice already. We'll just generate a few more and see what's going on. And this is the second one. This one's a little bit more bold. And let's just go one more for a third one. And here you are. This one is a more muted version. Now let's go ahead and first upscale these and then turn them into other maps. So if we have a base color map, I'll show you how I can turn this into a normal map, height map, etc. This is a very simple upscale workflow. All I need to do is just put in a load image and then a load upscale model. So right here, I'm using Ultra Mix Balance. Then I just add a save image node and just cue the prompt. And then there you have it. This is the 4K image and you can see, yes, it looks very high resolution. So let's take this into the next software, which is going to be Adobe Sampler. Adobe Sampler also used to be known as Substance Alchemist. So here we are in Adobe Substance 3D Sampler. This is a paid software. If you don't have this, then you could use something else called Deep Bump. However, that doesn't give you a roughness map, so that's why I prefer to use this instead. It's pretty straightforward to use, and it uses AI to convert a color map into all the other maps that you need. So just click on create new up here, and then you can just drag your image over here like so. It'll say image to material, pick this one, and it says AI powered. So there we go, import that. Okay, so it's loaded in now. Usually you don't have to do too much, but if you want to see what your 2D texture map looks like, go over here and click on 2D view 2, and then you can click down here to see normal, like that, roughness, metallic, height, etc. So there you have it. If you don't know how to read these maps, it's pretty simple. If it's darker, that means it's going to be less rough, and if it's brighter in value, it's going to be more rough. Less rough means it's going to be shinier, and marble is generally kind of shiny. So I'm going to go up here, in here, image to material AI powered layer or stack. You can change your roughness here, so I'm just going to invert it. It's a little bit darker, and then just raise it up a little bit like so. Then it's a little bit shinier here. Okay, and then if I want to make any other big changes, I could probably change the normal map if I want it to be stronger. So this is the normal. If I change large details, you can see it happening right there. Medium, micro, maybe micro a little bit on large. And ambient inclusion, pump that up a little bit. Yeah, that looks pretty nice. So once you're happy with what you have here, you can go over here to this button, share, and this is how you're going to export your textures. So click on that, export as, and you can go 4K if you want, but this is just for visualization purposes. 2K will be just fine for me, and I'll call this marble01 and export. Here I am back in Blender. I already have all my objects from MVDream in here, remember? So we want to create the marble floor of the room. Let's just go ahead and create a plane, like so, scale it up. Control A to apply all the transforms. And then I'll pull out a second pane on the right side and go to my shader editor. So to create a new material, just click new, and then create a fake user. Click on this shield icon here so your material isn't lost when it's not being used. Call this marble floor 01. And next up, you need to have the node wrangler enabled. So if you type that, it's an add-on that ships with Blender, so all you have to do is just checkbox it and make sure it's enabled. Once you have that, you can use a shortcut Control-Shift-T, and then this will bring up the window. So go ahead and select where your textures are exported to. Mine are here in miscellaneous textures, Marble 01, and just press A to select all of those. So once that's selected, go ahead and click this button here, Principal Texture Setup, and it sets up everything for you, including the displacement. So let's go ahead and just go to Render View and see what it looks like. And my lights are off, so I'll turn on my lights. Yeah, that looks pretty good. Let's see. Maybe I won't use the lights for now, and I'll just use Scene Lights, Scene World, yeah, Scene World. Turn that off just to see what's going on here. So some of the details might be a little strong. Scale of the displacement. So that's pretty low now. Should be fine. I think this is a good start. Now that I have a preliminary floor blocked in here, I want to open up the reference image. Usually you can use something like PureRef. However, you can also look at it in here. So if you drag this up and have another pane, you can go to the image editor, and then you can see here that I've already loaded in the image. So I'll just redo the process here. And I think it was this image. So now I have this here and I can see how it looks and compare. Let's go ahead and visualize here. Maybe the marble floor is not exactly what I expected. Perhaps I should add more of a metallic flair to it. So I think I'm going to go and generate another metallic texture using the same method of generating the texture using my own stylized model or fine-tuned model. Got my own metal textures like these. And I'm going to go ahead and do the same thing in Substance 3D Sampler to convert these to maps that I can actually use. The conversion process is finished, and I'll just show what some of the metal textures look like. This is the first one. And then I have metal 2. Like that. And then lastly, I have a metal 3 that is a little more tinted to the blue color. However, I can always change the tint using the base color and then adding some kind of hue shift node. So not a problem here. Here's my PureRef file with the image copied over. I was using the image editor, but I might need that space later. So I usually have my reference over here. So you can see that the focal point is this desk and then also probably this chair. And I will have a character sitting in it. Let me bring up the objects that I have right now, which are right here. So I can very quickly just select the chair that I have and deselect everything else. I'll just pull this collection outside and turn everything else off here. So I have my chair here. Now I can decide to either work on the table or I can block in the walls. I'm also not so sold on the design of this chair. I think I did point out the chair that I really liked. Before I block in the walls and the ceiling, I'm actually going to show another technique. There exists a software on the market right now that can turn a 2D image into a 3D object like so. It's developed by a company called Common Sense Machines. However, the methodology is closed source and they do offer a free option right here. But I would say like the Maker or Creative Pro will give you higher or better quality on your mesh. However, for the purpose of just showing you that there's another option here to get 3D objects from 2D images, you can try using this. So you can take me to the Cube app right here. And I've already generated the chair here that I wanted. However, I'll just show how to use it. So it's very simple. Just click on Upload Image. And you can either generate through Discord if you want. I've never tried using this, or you can drag and drop or upload an image right here. So let's just find another chair that I liked. So my image has been uploaded, and if you click on it, it'll start doing a preview here to show you what it'll look like. You can use the newest version if you want, so 1.1, generate preview mesh. It'll give you a very rudimentary mesh here after a while, and then if you like what you have, you can just click on refine mesh to get the final mesh. So that's the idea here. Once you've finished refining your mesh, you can go ahead and download it over here and then click on OBJ for the refined mesh. I've already done it, so I don't have to. And it'll give you a zip file that you have to unzip, and then you can import that object. Brought in the chair and put it in front of the MVDream chair. And let's go to rendered view just to see what we're working with. So this is what I have. What I can do, I'm not sure if I will do, is try to maybe take apart some part of the mesh here. I'll delete some parts of the mesh and then photo bash, if you can imagine it, these two meshes together, but we'll see how that goes. First, I want to build out more of the scene, so I think I will go with the walls next. So I'm going to stop the video here, but don't worry. I plan on making this world building with 3D and AI a multi-part series. In this video, I went over the MVDream theory, how to install it, and some basic blue sky concepting techniques with 3D models and textures. If I recorded more of the 3D process, it would take more time to release this video, and the runtime would also be 2 or 3 or 4 hours. So I decided to release just the first part like so in case people wanted to explore MVDream, but were a little intimidated by the setup. Thanks again for watching, and thanks to all the patrons. See you next video. Bye.